Yeah. So as of now, we have created pods manually, right? As of now, we have created pods manually, manually using pod manifest YAML file, right? So, so if we delete we delete our pods, if we delete our pod, Kubernetes not recreating, Kubernetes not recreating the pod, hence application will be down, right? Your application is where your application is deployed. Your application is deployed in the pod. In this pod, there is a container. In the container, your application is deployed, right? So if pod deleted, so for example, kubectl delete all, it will delete all the pods. Then your application will be down, right? For example, delete pod, delete a pod. So it will delete, right? kubectl, kubectl delete pod. For example, if the pod is deleted manually and check pods, check the pods. How to check the pods? kubectl get pods, right? If the pods deleted manually using pod manifest file or something like this command, if we delete our pod, Kubernetes is not recreating the pod, hence our application will be down, right? Hence our application will be down. So I don't want to down if the pod is deleted. I want to create a, so it will create automatically another pod. So how you can do it? Pod is not recreated because because so we have recreated because so we have created pod manually, right? We have created a pod manually. What is this, guys? It is not all recommended to create the pods manually. It is not all recommended to create pods manually. It is not recommended to create pods manually. So how you can create? How you can create? How you can create, guys? All we need to create. Always need to create the pods using below Kubernetes components or resources. So resources. So what are those, guys? What are those components? So we can use replication controller. Replication controller. Second one is replica set. Third one is deployment. Fourth one is stateful set. Fourth one is stateful set. And fifth one is daemon set. Okay, daemon set. So pod service, so that is not the recommended way. So what is the recommended way? Why we are not creating manually? Because of pod will not recreate if it is crashes or deleted. Right? Always we need to create the pods using the below Kubernetes components or resources. What are those? Guys, speak out. What are those?
Replication.
Replication controller, replica set, deployment, stateful set, and daemon.
Demon set.
Okay, so these all are the ways to create the pods. So what is this? Replication. So replication controller. What is that? So replication controller. So replication control is nothing but a RC. What is that, guys? So replication controller. So how you can create the pod by using replication controller? What is the replication controller? So replication controller, it is a Kubernetes component which is used to create the pods. What is that? It is a Kubernetes component which is used to create pods, which is used to create the pods. So and it will make sure always given number of pods are running for our application. Given number of pods running for our application. It will make sure always given number of pods are running running for our application. This replication control is, for example, they will give five. So how many pods will running? So we'll running five pods. For example, so fifth pod is crashed. It automatically create the another pod. So that is the nothing but a replication controller. We will set the replication controller for the pods. So whatever we set, right, it will create. If it is deleted, it will create. You will create another pods. Another pods. Node. So what is the node, guys? Node. It will create. It will take care of pod life cycle. What is that? It will take care of the pod life cycle. So it will take care of the pod life cycle. When pod is crashed or damaged or or deleted, then RC means replication controller will create new pod. Will create the new pod. Guys, understood? We can scale up. We can scale up and scale down pods count using replication. So using replication controller. Guys, understood? Pod is crashed or damaged, deleted, then the replication controller will create a new pod. So when we scale up, when and will we scale up and scale down the pods, count using replication controller. So replication controller. So what is that, guys? What is the replication controller? How you can add the replication controller? Okay. Yeah, we will take the old example, guys. AWS DevOps material. The AWS DevOps material, if you go Kubernetes, in the Kubernetes, there is a simple SVC, pod SVC, namespace also we created. Right? Yeah, we're taking this. What is this, guys? Nice. What this contains? RC replication. So replication controller dot AML. For example, this is the API version V1. So what is the kind, guys? Kind will change it to, tell me, guys. What is the kind? Replication. So kind is replication controller. So metadata name Tomcat 9. So label equal to my Tomcat. Okay. So what we will provide here. So we'll provide the label. So without label we can removing this label and spec. Spec contains what? Spec contains, guys. The spec contains replication, replicas. Replicas, how many replicas? We need a 3 replicas. And the select pro. So selector. So selector, which is the selector? The selector is, what is the selector? Selector is app. Selector is app, Tomcat 9. And so, and what we can create? Yeah. So this is the spec, right? Spec contains, this is one spec. I am creating another spec, guys. A spec contains, so we have a file. Let's take that file rc.yaml. Yeah, replication window. We have it. Okay. So what is that? So API version v1, kind replication controller, metadata, name my Tomcat 9. So spec replicas 3. How many replicas? 3. How many replicas we need, guys? We need 3 replicas. Selector. So this is the app my Tomcat. What is that? App my Tomcat. Template metadata name equal to my Tomcat. Label equal to app my Tomcat. What is that? So here we specify the label equal to selector. So selector and label. Okay. Selector and label. Spec container name equal to my Tomcat 9. Image from this number. Port container 80. So then, so if you use the replication controller, this will be adding, guys. What will you be adding? It will be adding the replicas. Replicas we can specify it in the spec. Okay, so in the replicas, which selector you know? So the selector is Tomcat 9. Okay, selector app equal to Tomcat 9, template metadata name equal to Tomcat 9, labels app equal to Tomcat 9. This is a Tomcat. Okay, then containers Tomcat 9, image is from port. So then API version, client service, metadata, my Tomcat 9, spec type equal to node balance or load balance, node what or load balancer, selector. So here you see, so where you need to add that add the that service. That service will be added to the my Tomcat selector app equal to my Tomcat. Okay, now you understood? This selector will be connected to the labels. So label. Okay. So this is the replication controller file. Replication controller ML file. Understood? So how you can apply something like you can apply by using kubectl delete all all hyphen all. So next kubectl kubectl apply hyphen f. What is that, guys? application controller data. Okay, this is the one. Next, what are the parts are created? Where the parts are created? kubectl get parts hyphen o by next one kubectl get svc kubectl get rc get rc kubectl right. So this is nothing but a kubectl. Now how many parts are running Tomcat parts? So we have a so here we need to check. We need to create the word variable. Okay. So SVC means it will show the SVC. Parts means it will show the parts. So RC means it will show the application controller. Application controller. Keep CTL. Scale RC. Scale RC. My Tomcat. My Tomcat. What is that RC name? My Tomcat name. Okay. SVC name, RC name. Everything is my Tomcat. Right? Hyphen hyphen. Duplicas. File. You will change it from we will change it how many? 3 to 5. So I want to scale up my RC. So scale up my replicas. I want to scale down my replicas. Okay. 3. Replicas will be change it to 3. Okay. I want to delete the replication controller. How you can delete it? kubectl delete. What is it? My tomcat 9. My tomcat 9. Is understood? Understood, guys?
Yes, yes, sir. Sir,
One.
clicks are three.
Hmm.
kubectl scale RC my town fragment.
Voice in which kubectl
kubectl RC
kubectl
please share.
నీ వాయిస్ చెప్పు రామ్కి రామ్కి asking something, right?
Replicas, sorry, kubectl. Yes, sir. kubectl RC replicas are replics.
replica next replica set we will tell you replica set. So manually pod is not recommended. So what is a replication controller? So replication controller is a providing facility to create multiple pods, and it will make sure pods always exist to run our application. Using replication controller, we can achieve high availability. Okay. So replication control and pods are associated with the labels and selectors. So labels and selectors. So replication controller. So it is a Kubernetes component which is used to create the pods. It will make sure always number of pods are running or application. It will take care of the pod lifecycle. When pod is crashed, damaged or deleted, then RC will create a new pod. So we can scale up and scale down the pods count using the replication controller. So what is that? So this is the replicas. You're asking this one, now,
Yes.
right? Replicas. The command is replicas. What I read, what I write. Okay. So manifest file creation, pod manifest file, API version, kind metadata spec, node port service main file, API version, kind metadata spec. Okay, manifest file. So replication controller, kind equal to replication controller, mate equal to Java, and replicas equal to 1, selector equal to API Java, template. So labels. So labels, selectors is the main possible. So spec, this is the spec one. Okay, this is the service one. So in the replication controller, we provide the replication controller. How many replicas we need? So replica setter. What is a replica setter? Replica set is a replacement for the replication controller. It is a next gen component Kubernetes. Replica set is also used to manage pod lifecycle only. So replication controller or replica set both are same. Also used to manage the pod lifecycle. Replicate set also will maintain the given number of pods always. So when we scale up, when we scale down our pods using replica set also. So the only difference between replication controller and replica set is selector. So selector. So we are not using the selector, right? So based on the selector, it will change. So difference between replication controller and replica set. The only difference between replication controller and replica set is selector. The replication controller supports equality based selector. What is this? So equality based selector, and replica set is supports the set based selector. So replica selector is nothing but a app Java app. So set based selector is nothing but a so selector match labels app Java web version type. So it will provide the labels on the selectors. It will provide the labels on the selector. So match label. So what is the label, guys? Label is label equal to Java app. Label equal to Java app. So here, match label is equal to Java app. We provide the version and the backend and type equal to backend. Examples of equality and set based selector also. Equality selector and set based selector. Okay. Replica set, replication control. The only difference between replication control and replica set is a selector. So the only difference between replication control and the replica set is a selector. Replication control supports a equality based selector and uh, that that match labels so different one. The replica set supports the set based selector. So set based selector. So this one is replication controller is a equality based selector. So set based selector equality. What is set based? What is equality based selector? Equality selector example equal to selector web app Java web app. Set based selector equal to in the selector we can provide the match expressions, key, operator, values, everything in the set based. It will set the selector. But so what is the equality means? It will already set the selector. We will already set the selector. So replication control versus replica set in the Kubernetes. What is the difference between both replication control and replica set is selector. So which selector replication control replication controller uses the equality selector and the replica set uses the set based selector. Set based selector. Right, replication control versus replica set in Kubernetes. So it can be considered as a replacement or organization controller. The replica set and the organization controller key difference is the key difference is that the replication controller only supports equality based selector, where the replica set supports set based selectors. Okay, so daemon set. So what is a daemon set? A daemon set ensures that all nodes running a copy of the pod, a node are added to the cluster. Pods are added them. As nodes are removed from the cluster, those pods are garbage collected. Deleting daemon set is clean up the pods is created. Deleting daemon deleting daemon set is nothing but it up to pods are created. What is ELK? ELK is nothing but Elasticsearch, Kubernetes and Elasticsearch ELQ. Elasticsearch Logstash and Kibana. Elasticsearch Logstash Kibana. What is this is case? ELK Elasticsearch Logstash Kibana. So in the Kibana provides a UA for Elastic. So Kibana will provide the UA for Elastic. So Logstash will collect the logs, transform to the JSON message and feed them into Elastic cluster. So Logstash. So we collect the logs and read the logs and move it to the logs. Okay. What is a daemon? A daemon set ensures that all nodes run a copy of the pod. As node as nodes are added to the cluster or pods are added to them as nodes are removed from the cluster, those pods are garbage collected. Okay. So deleting the daemon set will clean up the pods created. Some typical use cases of determine so daemon set are so running a cluster storage daemon on every node, running a logs collection daemon on every node, and running a node more, running a node monitoring on the every node. Replicas not applicable for the daemon set. Replicas are not applicable for the daemon set. It applicable for the only replica set. Daemon set. So what is daemon set? It is a Kubernetes resource to create the pods. Daemon set will create a one pod in each worker node. When we add the node to the cluster, then the pod will create it. So if we remove the node, the cluster, so the cluster then pod will be created. So when we add node to the cluster, then pod will be created. If we remove the node, the cluster, then pod will be created. So what are the pods will be created? Logs collector and node monitoring. Pod creation ways. Manually pod created, not recommended. Pod creation using replication controller. Pod creation using replica set. Pod creation using daemon set. In above concept, auto scaling feature is not available. Not available, right? Replication controller, replica set, daemon set. The auto scaling feature is not available. Manually, we need to scale our pods. There is no option to roll back our pods, right? Our pod creation. To overcome these problems, we have a deployment concept. What is deployment? So, what is daemon set? Daemon set having some problems. Yes. So, manually pod created, not recommended. Pod creation using replication controller, pod creation using replica set, pod creation using daemon set. In above concept, auto scaling feature not available. Manually, we need to scale our pods. So there is no option to roll out or roll back our pods creation. To overcome these problems, we have a deployment concept. What is that, guys? Deployment concept. So deployment is one of the Kubernetes resource or component. So deployment is the most recommended approach to deploy our application in the Kubernetes. Okay, using deployment is the most recommended approach to deploy our applications in Kubernetes center. So next to using deployment, we can scale. Using deployment, we can scale up and scale down the pods. Deployment supports rollout and rollbacks also. And to deploy a latest code, we have to delete the RC and RS, the release control and request, then pods. Okay, so we can deploy the latest code with zero downtime using uh, zero downtime deployment and rollout and rollback and auto scaling. Rollout and rollback, zero downtime deployment, rollout and rollback and auto scaling. So deployment strategies. What are the deployment strategies, guys? So we have a below deployment strategies, recreate and rolling update. I already told you right morning. So recreate means it will delete all the existing pods and it will create the new pods is nothing but a rolling, no, recreate. So downtime will be there. So rolling update strategy means it will delete the pod, creates a new pod one by one. So if you don't specify the deployment strategy, that the default it will consider as a rolling update. Okay. So here recreate means directly delete all the pods. So there is a downtime. So here it will delete and one create, one delete and one create, one create and one create. Guys understood? Yeah,
Yes,
so
sir.
deployment creation. All Kubernetes commands, so Kubernetes get pods, Kubernetes get SVC, Kubernetes delete all different. So Kubernetes apply enough format value, the kubectl they have kubectl get pods, kubectl get SVC, kubectl get deployment, kubectl development, deployment, delete deployment strategies. So strategy is recreated. Whenever there is a deployment.yaml, what you can do in the node we have a two parts are running. So if we use the strategy recreate, it will delete the parts and recreate the parts. What are the previous parts available? Those are delete. It will create the parts based on the replicas. Based on the parts based on the replicas, it will create. So recreate means existing parts will be deleted and new parts will be created. So application will not have a downtime or will have a downtime in the strategy of a recreate, guys. The strategy of a recreate, if the application if the application will don't have a downtime or will have a downtime for the recreate, guys. The deployment strategy, if we use the recreate, so the application will have a downtime or will not have a downtime. Will have downtime. Yeah, recreate means so it will delete all the parts. So the recreate means it will delete all the parts and it will create the parts. So rolling update means it will delete first part, then recreate, then second part, then third part. It will not. There is no outage of the application deployment. Right. If we use the status create, it will delete the parts and recreate the parts. What are the previous available? Those are delete and will create the parts based on the replicas. If you are using the strategy or if you are using the strategy, create, it will delete the parts and recreate the parts. What are the previous parts available? Those are delete and it will recreate the parts based on the replicas. So recreate means existing parts will be deleted and the new parts will be created. Okay, recreate strategy. Yes. So recreate strategy. One second. Yeah. So recreate means so what is the recreate strategy? So recreate means the strategy recreate. Kubernetes official document. What is the strategy? All existing parts are killed before new ones are created. When use the recreate. Okay. Rolling update. So rolling update means so rolling update, it will delete one by one pod and create one by one pod. Understood, guys? So recreate strategy and rolling update strategy. So the next one is blue green deployment, guys. What is that? Blue green deployment, guys. So we'll take tomorrow. So I will show you the practical also tomorrow. So blue green deployment model. So what is blue-green deployment model? Blue-green deployment is an application release-based model. It reduces the risk and minimizes the downtime. It uses a two production environments known as blue and green. The old version can be called as blue environment. The new version can be known as green environment. So rapid releasing, simple rollbacks, built-in disaster recovery, seamless customer experience, zero downtime. So that's the reason they are using a green and blue deployment model. Okay, so this is the blue-green deployment router. The router will be, the DNS will be routed to this server or this server. Okay, so version 1 and version 2. So V1 is still running. So that is with the proven models. Okay, practical. I will show you blue-green deployment model, guys. So deployment procedure. So okay, config maps and secrets. Once config map secrets completed, so then examples of a stateless application and stateful application. What is stateless? Stateful, state setup. So what is the difference between deployment and stateful setup? Okay, Helm charts. Helm package manager, Helm application, Helm charts, metric servers, Kubernetes monitoring, Prometheus, Grafana. So Prometheus and Grafana architecture. What is the LK? Elasticsearch Logstash. I will show you Elasticsearch and Logstash also. Okay, Elk architecture, fluent beat, auto scaling. So auto scaling. So less user accessing app, auto scaling. So horizontal auto scaling and vertical auto scaling. Request versus limits. I will tell you request versus limits. And AWS case we already know, right? So ingress, once ingress is completed, the Kubernetes part will complete it. Okay? Yeah. So we'll take the class tomorrow also, guys. Saturday, right? So, okay.
Okay.
Yeah. So we'll show you practical tomorrow. Replication controller, replica set, daemon set. Okay.